an industrial grid. Then I'm going to discuss the benefit of using hybrid energy storage in an industrial grid, the challenges faced in an industrial grid, and finally, some future trends and innovation related to hybrid energy storage when integrated with renewables in an industrial grid. So as we all know, there is today a growing interest in shifting toward renewable energy systems such as solar and wind due to the increasing carbon dioxide emissions worldwide. So we need to shift toward cleaner energy sources such as I said, solar and wind. However, these sources are intermittent, as we all know. So a solution to solve this issue is to use energy storage, which can actually store energy when there is an excess and discharge this energy when there is demand of this electricity. So energy storage, as you know, they have become a very interesting topic, and also the installation of energy storage has increased significantly throughout the years. So as you can see, there is an increasing trend in the installation of energy storage, and we are expecting this trend to continue in the next upcoming years. So if we look also at the share of the total installed capacity, we can see, for example, that pumped hydro energy storage make up the largest share, so of about 92% of the total installed capacity energy storage worldwide. However, this energy storage system actually faces a lot of limitations, such as the geographical limitation. So that's why today researchers are interested, and also startups, they are interested in developing some energy storage systems that are based on the well-proven principle of pumped hydro energy storage, such as the gravity energy storage. So I'm gonna, in few, discuss this energy storage type. I have like a couple of slides just to introduce you to this new and promising energy storage system that we may see in the future. I guess my colleagues did already define what's a hybrid energy storage system in the previous presentations. So it's actually about combining two or more energy storage systems, and we can actually use different energy storage systems in this case, which can be combined, of course, to store energy and discharge when there is a need. For example, we can opt for two categories of energy storage. So we may categorize them according to, for example, high energy storage or high power storage. So as you can see in this schematic here, so for example, the high energy storage, these are the ones that are responsible for handling long-term energy storage because of their characteristics, which are high energy density. The high power storage, in this case, they can absorb peak and transient power because of their high power storage, high power density, and rapid discharge time. So, which is very interesting characteristics. So we, as I said, we can have these two components. We can have more or other energy storage that can be used. So in the next slide, I'm gonna be talking about some few energy storage that we can, or the common energy storage that we can find in an industrial park. So we can actually categorize them according to electricity storage, so which means we convert electricity in different forms, such as the electrochemical. So here we're talking about batteries. As you know, we have different types of batteries. We can convert it into physical, such as the pumped hydro energy storage, compressed air energy storage, flywheel energy storage, and so on. And we have also the electromagnetic energy storage, such as the superconductors. Other category could be the thermal storage. So thermal storage As you know, we have the sensible, the latent thermal storage, and the thermochemical thermal storage. So these are characterized by they are in economical, environmentally friendly, and they have high energy density. So some of these technologies, they have also some drawbacks, such as the high losses and the low efficiency. So other types are the gas storage. So here we're talking about power to gas, so which means we convert electricity into hydrogen or methane. So we can, in this case, store electricity in the form of these hydrogen, as I said, or methane. So we can store them. So they are characterized by a high energy density. They have also, we can actually benefit from the long distance transportation. That's a good advantage, but still they are expensive. So the equipment is expensive because they are not mature yet. And other storage are the V2G, which means the vehicle to the grid, V2G. So here we're talking about electric vehicles. We can also talk about hydrogen vehicles. So these energy storage system, as you know, they have different characteristics and they can be used in different applications. So I guess my colleagues in the presentation before, they did discuss a little bit the different applications in which we can actually match these energy storage systems. So as I said, different energy storage, they have different storage characteristic. So in order to combine this energy storage, we have actually to look at what's the objective of the hybridization. So what we would like to get when hybridizing the different energy storage. So we can look, or we can actually have a look at the different characteristic of these energy storage. For example, we can find lithium batteries. They have a high energy density compared to supercapacitors. So in this case, they have a very low storage capacity, energy density, sorry, the energy density. So however, if we look at the power density in this case, the batteries, the lithium batteries, they have a low one, while supercapacitors, they have a high power density. So which means in some cases, we can combine the two so that these two technologies can be complementary. So they can offer complementary services to the grid because of the different characteristics they have. So it's also important to talk about the benefit. So why are we going to hybridize these energy storage systems in order to benefit from all the advantages these hybrid energy storage they offer to the grid? And we have here some of the benefit. So the first one is the grid stability. So I'm going to be talking about the different benefit in the next slide. So all of them, because I know that some of you come from different backgrounds. So that's why I'm going to try to explain this benefit more. So we have an increase of grid stability, an increase of the reliability. So we can also, the hybrid energy storage can offer both different services, such as peak shaving or peak shifting, frequency regulation. It can help also industrial to integrate more renewable. It's enabled to reduce the energy cost, to lower carbon footprint, to also lower our reliance on the fossil fuel. It enables industries to meet the load demand. It enables also prolonging the energy storage lifetime. And finally, it offers technological complementarity. So as I said before, I'll be explaining this in more details especially for those of you who come from different backgrounds. So the first one, which is the grid stability. So here we're talking about frequency regulation, which means regulating the frequency up and down. And the main aim is to smooth out the fluctuations in the renewable energy. As we know, the output variable production. So which means energy storage or hybrid energy storage can, in this case, rapidly absorb or inject power in order to maintain a stable frequency. So that's the main objective, and it's very important for the industrial grid. So the second one is about increasing reliability. So in case we have, for example, a damage in a power line, so in order to avoid outage, in order to avoid disturbance, so we need to have like a reliable power supply. So energy storage can, in this case, ensure a continuous power supply especially for critical industries. So critical industries, for example, we can have let's say data centers, hospitals. They need to always have a reliable supply. So in this case, the hybrid energy storage can actually ensure this continuous power supply. So another important benefit is about peak shaving and peak shifting. Again, my colleagues before did talk about these points. So the energy storage, they actually facilitate these services, which are peak shaving and peak shifting. So for those of you who do not know the difference, so as the name indicates, peak shifting means you shift the load to other periods. So for example, here, when we have peak loads, we just shift the load to the other periods. So peak shaving, it means we reduce our load in order to decrease the demand of energy. And energy storage, in this case, that can facilitate both services, which are peak shaving and peak shifting, by, of course, storing electricity when we have an excess and discharging it when we need this electricity. And it enable industrial parks to save money, because in this case, they're gonna avoid or lower the what we call the demand charges. So as you know, the industrial and also commercials, they have to pay what we call a demand charge. So by actually lowering their peaks, they will lower these charges. So it's very interesting, and also it enables us to reduce our reliance on expensive peak grids. So as you know, during periods of peak demand, usually we may use some peak power plants. So peak power plants, it could be, for example, natural gas plants, which are expensive, which are dirty. And also in order to avoid them, we can discharge energy from the hybrid energy storage system to avoid these costs. So another important point is about integrating more renewables. So by the use of hybrid energy storage, the industries can integrate more and more renewables, because they enable them to benefit from all the benefit we have seen here. So for example, if we look at the first graph, if we don't have energy storage, you can see that sometimes we may have some wasted energy, and we may be obliged during peak periods to use, as I said, peak generation, which are usually inefficient and dirty. So if we use hybrid energy storage, in this case, we can avoid this scenario. So we can store the excess electricity and discharge it later on when there is a need of this electricity, to avoid using these peak generation systems or technologies. So of course, if we reduce or integrate more renewables, we're going to be reducing the energy cost, since we are not going to use expensive power plants. So in this case, we're going to discharge energy from energy storage. So it enables us to reduce our reliance on these expensive plants, save money, and also the industries can benefit from what we call the time use of rate advantage, which means the storage of electricity when the prices are low, and the discharges of this energy when the prices are high, and this will make them to actually make profit and save money. So when talking about integrating more renewables, so we have also we're going to reduce our carbon footprint. Since we're gonna be using, as I said, renewables, we're gonna reduce our reliance on fossil fuel. This means less emissions of CO2, and this means also we're gonna mitigate climate change. And also it enables industries to benefit from carbon credit in this case, since they will have lower carbon footprint, lower emissions. So for meeting the loads. So as you know, in general, industries, they have diverse load. So they have electrical load, heating load, cooling load, and also gas load. So we have to meet all this load. And in order to be able to meet this multifaceted load, so we have to use hybrid energy storage system. So I have here an example that I will show in the next slide. So it will enable these industries to meet the load and to have like a reliable energy supply. So an example is shown here. For example, we have a PV system that's been connected to diverse storage. We can find, for example, battery energy storage. And we have diverse load. We have the electric load, we have the heating load, we have also the gas load, and we need to meet all this multi-phase load from the renewable energy and along with the hybrid storage. So in this case, for example, the production of the PV system can be directed or injected directly by the electric load. It can be injected to the grid. So the remaining, or it can be stored in batteries. The remaining electricity can be used by power to gas, for example, for the conversion of this electricity to a gas. It could be hydrogen or methane. And this gas can be either stored in a gas device or injected directly to the gas load or injected to the network, the gas network. So in order to meet the heating load, in this case, we can use either the air source heat pump. We can use the heat from a storage tank, as you can see, or we can use the waste heat recovery from the gas turbine. So these are all the different combinations that, for example, an industry can benefit from if they have like a diverse or hybrid energy storage system. Another interesting benefit we can or the industry can benefit from is the prolonging the energy storage lifetime. So for example, if we combine, let's say, batteries with supercapacitor, so in this case, we're going to avoid the frequent start and stop cycles of batteries, and also the instantaneous high power charging and discharging of these batteries. And this will enable us to extend or prolong the lifetime of our battery. So because of the characteristic of both technologies, which are, you can say that they are complementary. And again, I have an example of this one I will show in fuel. So the technological complementarity, again, in this case, by having a hybrid energy system, we can benefit from the advantage of each technology. As we have seen in the previous example, but with the supercapacitor, we can only harness the strength of each system. And this will enable us to have like an efficient and also comprehensive energy management in our industrial grid. So here is the example of power to power hybrid energy storage system. So we have a renewable energy system in which, for example, we have batteries and supercapacitor connected. And because of the characteristic of each, which we can see here, so usually batteries, they are considered as an energy type storage. Supercapacitor, they are considered as a power type storage. So because of the characteristic of each, which are the high density of batteries and also the slow discharge time, they can actually handle the low frequency fluctuation of renewables. So unlike the supercapacitors, which are characterized by high power density, so high power density means they have a high rate of power output relative to its volume and mass. That's what we mean by the power density. So, and also they are characterized by high instantaneous charging and discharging rate. So they can, in this case, handle high frequency variation. So which means in a renewable plant, which output variable power, so we can handle both the rapid and slow variation, and also the small scale and the large scale variation or the fluctuation of these renewables by the use of these two energy storage systems. So these were the benefit of different of hybrid energy storage system. As you can see, we have different benefit. So, however, in order to adapt more hybrid energy storage system, we need to overcome some challenges, which we can classify as both technical and economical challenges. So for the technical challenges, mainly it's about the complexity of system integration. Since we're going to be dealing with diverse energy storage system, and each energy storage system has its own has its own standards and characteristics. So we need actually to develop some advanced control system that will enable us to have interconnection and communication between these technologies. We need to create or develop more optimized algorithm to have real-time management, to have also monitoring and also user interface in order to be able to integrate these diverse energy storage in the industrial grid. So talking about the economic challenge, so as we all know, energy storage systems, they are still expensive. So the cost of these systems need to be reduced in order to adopt them more. Also, we need to have some viable business models. So we are still uncertain about the ROI of this energy storage system. And also we need the regulation. We need regulation and standardization of these systems. So there is a lack of regulation in different countries, and again, it varies from one country to the other. So in order to be able to adopt more energy storage. So these were these are the challenges. So, however, we have some positive points. So, which means there is some innovation going on. So we have some developments of some emerging technologies, such as the gravity energy storage I have discussed before. Actually, I'm coordinating a project that has received funding from the Center for Development of Industrial Technologies of Spain. And the aim is to actually build a gravity energy storage prototype. So when talking about gravity-based storage, actually we have different configurations. So we can see that some types, they make use of water, others do not. They use instead, for example, a wire rope hosting system. So in the next slide, I'm going to be explaining the working principle of this system, which is actually considered a new and promising energy storage system that we may see in the future. So there are actually today some prototypes that are being developed worldwide. For example, Energy Vault company, they are developing in China a 100 megawatt hour gravity energy storage. It's being built. And this is as I said, I'm going to be talking about this energy storage more in the next slide. So we have also some advance in a number of technologies, such as batteries. So most of you works on materials to look for new materials that can be used for batteries. And this is a positive point. So this advance in technology enable reduction of costs. As we said before, one of the main challenge of energy storage is the high cost, but we can see that the cost of energy storage they decreased over time. So, for example, here over in the last 15 years, we have the cost has fallen by about 90% of batteries. so which is interesting, and this cost is expected to decrease more in the future, so we can have or install more energy storage. So for the gravity energy storage, as I said briefly, I'm going to talk about how it works. I guess it's a new system that most of you do not know how it works. So it's actually consists of a large shaft in which we place inside the system a heavy piston, so could be made up of different materials. And in order to charge electricity, so we get electricity, excess electricity, that's used by the pump to push the piston up. So this is how we store electricity. So to discharge it, we just let the piston drop, pushing water in the opposite direction, and the water will drive a turbine that will drive a generator to produce electricity. So the working principle is simple, and it's similar to the working principle of pumped hydro storage. So the system can be built underground, so which means we can avoid the drawbacks or the limitation of pumped hydro energy storage, which always require like having two reservoirs being located at different heights, which is not always available in a lot of countries. So the system can be built everywhere. And also we have some prototypes that are being built in some old mines. So this will enable to avoid the excavation costs, because the main cost is mainly about the excavation. So to avoid it, we can use it, for example, in some old mines. So as I said, this is just one configuration of gravity energy storage. We have different configurations, such as the one here. So in this case, we don't use water. Rather, we use our rope hosting system to lift the piston. So we have conducted a lot of research about this system, and we have also 6 patents, such as, for example, combining the two technologies in a single one, and the objective is to increase the capacity. Or we can also combine it with the compressed air, so this enables to again increase the capacity. We thought also of removing the return pipe and placing the powerhouse inside the piston with the use of springs. So this also could work, and the idea always is to improve the technology. So why this system is interesting? Because of the first one is the high efficiency. So we're talking about an efficiency of 85%. It has also an interesting levelized cost of energy, LCOE, that is competitive with some energy storage system. So it has a high response time, and it has a long lifetime. We're talking about more than 50 years. So similar to pumped hydro energy storage. So another point is another advantage is about the development of smart grid. So smart grid today enable us to overcome the technical challenges that I have stated before, because as I said, we need to have like some advanced control system. We need to have communication and so on. So smart grid enable all these features. It enable the communication between the different technologies. It enable also detection of fault and also monitoring and so on. We have also, today we can use artificial intelligence. As you know, it's been used for the models, for developing models, energy management models, and we have already done that. So for example, so the first schematic here, we try to combine two technologies, which are gravity energy storage with batteries. So this is a study that we have done. So we have proposed the energy management of this hybrid energy storage system to meet an industrial load. We thought also of combining for a residential gravity energy storage with hydrogen storage in this case, since we're using a hydrogen car and also versus an electric car. And we thought also of integrating batteries. So this model, we have done it using artificial intelligence. So these two studies are currently under publication. So today, as I said, a lot of researchers, they're trying to propose and develop energy management models. So finally, the final point is about policies. I guess my colleagues did talk more about this. So in order to adopt more energy storage system, we need to have policies, and the government need to promote more renewables and energy storage in order to be able to use them more in the future. So for example, they need to set target for renewables. We need to have some financial incentives and subsidies provided by the government. And again, this differs from one country to the others. We need to do research, and we need also some to receive fundings for the development of this research. We need to have some standards and regulation in order to be able to integrate hybrid energy storage in an industrial grid. We need awareness and also education, such as more summer schools, in order to make people aware about the importance of, for example, hybrid energy storage in an industrial grid. And finally, we need international collaboration in order to be able to reach our goals. So as a conclusion, so we can say that it is a promising concept. Hybrid energy storage is a promising concept which enable industries to actually benefit from a lot of services. So we can benefit from all the discussed benefit I have stated before. There are still some challenges, both technical and economical, that we need to overcome in order to be able to see more hybrid energy storage system being adopted worldwide. That's all. So thank you very much. And I'll be happy to answer all your questions.